Hey, good morning. It's day 163. Do you want to know how to make one of these disappear? Here, Luna, show them what you have. Here, bring it over here. You want to learn how to make one of these disappear?
Do we need water?
No, we need, here, Jackson, bring that over here. Hold it up. Yeah, all you need is, hold this up. You're not holding that up. One of these. That thing that Luna just showed you, a little test tube. And what's this? Do you know what that is?
I think it's apple cider.
You think it's apple cider? No, Luna, what do you think it is? It's not apple cider.
I think it's nothing.
You think it's nothing? It's oil, vegetable oil. So those three things, we can make stuff disappear. And normally in class, you would be doing this today, but we're not there. Here, leave it alone, buddy. It's not time yet. No, thanks. It's not time yet. But I'm going to show you how to do it on here. And we'll do it. Oh, hey, baby. Shh. We'll show you how to do it on here. I'll do it for you and demonstrate it, and also show you a video where somebody else does it, and you can take a look at how they did it.
How will these?
All right. So our essential question for today is, how can I prove that light is a wave? And we're going to see how to do that today and tomorrow. How we can prove the light's a wave. We're going to define a couple things related to refraction today. So define refraction, and then use refraction to explain why light bends.
Why are you not being quiet?
Oh, okay. Because I'm making the video, so I have to talk.
Me too.
You're not making the video. You're supposed to be quiet. All right. For your warm up, I want you to take a look at this image right here. Okay. Luna, what's in that picture?
A cup.
A cup and
a straw.
A straw. And does the straw look like it's in one piece, or does it look broken?
It looks broken.
Is it broken?
No.
No, it's not. So, describe its appearance. Say why you think the straw appears split, and then come back and we will answer. So we got a few answers here. One, you can click on this link and take a look at what it says. And then also, if you decide that you wanted to show this to, say, a sibling, or maybe even your parents, you could use the instructions that are right here to help you do that. So why does this thing appear? Oops. Wrong link. Why does it appear that it's broken? Well, you got to think about where the straw is in the two separate parts. So this part up here, Luna, you gotta be quiet. This part up here, where is this straw? Is this straw in the water or in the air?
In the water.
This part, it's in the air. All right, and
then the other part, it's in the water.
Yes, it's in the water down here. We also have this part here. Think about, how is that image traveling to your eye? It's not just traveling through the air. It's also traveling through this thing, the glass. And so you can see that sometimes that bends the light a little bit, like right here. But the big change is right here when the straw is in the water. And so it appears like it's split, but that's because the water is bending the light. And why does the water bend the light? Well, that's because water and air have different densities. One of these is much heavier per unit of volume.
Look, wait, you get.
What do I get? I get a Huggy?
Yeah.
No, thanks. So, the water's much more dense, and things that are more dense slow light down. Just like if you were trying to maybe run through some water versus running through air. Right? If you ever run through the water at the beach. Okay, so back. Light traveling through two different media, right? Two different mediums. Media is how you say that. the light is going to be traveling at different speeds. When it speeds up or slows down, it gets bent. And that's called refraction. Okay, so now we're going to look at a little slideshow on refraction, and that's here. And let's go to page 1. There we are. All right, so we're starting off with a little something to think about here. And that is a car driving along a highway, and suddenly it hits this shoulder. And what's this shoulder made of? This part of the road over here. It's not hard asphalt like this. It's usually made of gravel. So it's soft. Maybe this is kind of like riding your bike into sand. If you've ever done that before, or your skateboard, it's kind of a no-go, right? It grabs your wheels right away. So if the right front tire is what contacts this first, well, what's going to happen with that tire? What's it going to feel? It's going to feel some pretty strong forces trying to slow it down. And so that's going to cause the car to go straight or turn to the right. It's going to cause it to turn to the right. Right? It's going to basically drag the car. Well, that looks like the left to you, but it's going to cause it to turn to the right. And that's because there's more friction on the right side of the car than the left, because the right side tires are in the frictiony material and the left side tires are not. So the car turns, or its path bends. And this is a good analogy for what happens with light. When light goes through a denser medium where there's more resistance to it passing through, you get a bending or refraction. Moving on, next slide. So this is just a summary of what we've been saying. Light will go straight, right? Because the easiest path for it to take, the shortest distance between two lines, or shortest distance between 2 points is a straight line. So it does that at a constant speed as long as it's going through one medium. But as soon as it passes from one medium to another, the denser medium slows the light down. And we did the example with the water and the air, and that bending that happens is called refraction. And so, got a little demonstration. So I'm going to ask you to sketch it in your notes, and then say why the popsicle stick looks bent in the glass of water. All right, so just a little review. And there we go.
Hi, I'm Becca, the Educational Outreach Manager at Edmond Optics. Today we're going to talk about refraction of light. Refraction is when light bends when it travels from one medium to another. A medium is any substance. Here I have a glass of water and a popsicle stick. I'm going to insert the popsicle stick into the glass of water.
Right now you might be wondering, did she say that? And the answer is, some of these are kind of funny. The answer is yes. As you can see, last year I liked some of these comments. Water, popsicle. We're all different, guys. It's all right.
As you can see, it appears that the popsicle stick bends at the barrier between the air and the water.
Good job, buddy.
Refraction is caused by a change in the speed of a wave of light when it moves from one medium to another. Just imagine if you're riding your bike on pavement and suddenly cross over to sand. Your bike is going to slow down when you move from the pavement to the sand. The same thing happens with light. When light hits a more dense medium, the light wave is going to slow down. When it hits a less dense medium, it's going to speed up. The same thing happens when I put this lens in front of my face. The light slows down and changes direction, or refracts, making my eye appear smaller than it actually is. An array of light traveling from a less dense medium, the air, to a more dense medium, the water. When the laser light travels from the air and hits the water, the light slows down and refracts.
Do you see the bend?
If refraction did not occur, you would expect the beam of light to travel in a straight line. But since the light slows down and refracts once it hits the water,
see, buddy, this
it
is
bends
refraction
from its original course.
See how it bent?
Here I have a large beam of light traveling through a fish tank. When I put a lens in front of the beam of light, the light will refract. When I move the lens further away from the light source, the light will refract to a point.
All right, so for those of you who use magnifying glasses, this is an example of how they work, right, with refraction. And maybe you've noticed or known that you can focus light, especially sunlight, to a point, and it gets really hot because you're focusing all that energy into one little spot. You do all kinds of things, like you could burn the ground or a piece of paper. It makes it really hot.
In most cases, when light waves speed up or slow down, they change direction. I am shining laser light through an optic. The laser light is starting at 0 degrees, but when it hits the optic, it slows down and slightly bends. The laser light then comes out at 4.5 degrees. So now we know that refraction is the bending of light, and that light travels more quickly through less dense materials, and it travels more slowly through more dense materials. Good scientists and engineers always test out scientific theories for themselves. To find instructions for these demonstrations, click
go to edmondscientific.com. All right. I think she took too many relaxers today, but that's a quality content video with lots of good images for you to see, examples of refraction. Hope you enjoy it. Okay, so coming back. So why does the popsicle stick or the papsticle stick look bent in the glass of water? Well, because the light hits the water and speeds up or slows down. Slows down, and so it refracts. All right, so this is where we would do our hands-on part. Materials you would use: beaker, test tube tongs, and some oil. So let's get those. Okay, so on the off chance that you have some of this stuff at home, which I highly doubt, but if you do, or if you want to try this with some glass, you can try it. It kind of works. But get your parents' permission first, because it means that you have to use some oil. You don't want to use up all the house's oil. You just want to be careful with some things. One, the oil is slippery, and if you mix slippery with glass, you can drop stuff, and it'll break. Normally, if the glass broke, I'd come over and clean it up, but I'm not coming to your house to clean up any broken glass, so that's on you. All right, so what we would do is make some observations, look at the appearance of this test tube, look at the appearance of this beaker, and think about how images on the other side of these things look. All right, so like looking at, say, me through this, you can see that my image changes, right? I get Summer Beach Ready through the beaker, and then I get normal outside the beaker. Beach Ready, normal. Beach Ready, normal. Same thing happens here to a more extreme extent. All right. See that? So that's just from the Pyrex, which is what this is made of. You may have something that's Pyrex, like a measuring cup at home. Okay. So let's put some oil in here. There we are. Now this is interesting because my image has been reversed. cool. But that's not what we're here to look at today. So let's take a look at putting this in here. Can you see it? You can, right? Do you know why you can see it? What's inside the test tube? Air. All right? And that air is a different density than the Pyrex, and it's also different from the oil. And so the light going through here goes through transitions and bends. Okay, so let's see what happens when we submerge this in oil. Where'd it go? Do you see it? If you have good eyes, you can see it. It's still there. This isn't perfect, but it's essentially disappeared. So, why did it do that? What was different between the tube with oil and the tube without? The tube without, think about what it had in it. Clean up your materials. And think about why that happened. Now, to watch this in high resolution, you can go to the next slide and click right here and watch this great video where they do the same thing, but with some cheeky British attitude.
Morning Fiskin, and today I'm going to see if I can make an object invisible just using some vegetable oil and some Pyrex glassware.
Cool. Well, you can watch that on your own. It's a great video. I love it.
If you're looking to tone up or burn belly.
Yeah, cool. Great. Thanks, buddy. Okay. Almost done. So a little bit of stuff to think about. Who comes up with this stuff? Well, Pierre de Fermat. This guy is still relevant in physics classes. When I got my bachelor's degree in physics, we learned about him. So he studied math and in the 1600s, and he came up with a principle that said that light travels the path of least time. So light's going to go in the direction that makes it take the shortest amount of time. Yeah, see, you can't do that, dude. That's loud. Man. All right. So let's think about that. If we're traveling just through one medium from point A to point B, which would the quickest path be from A to B? What do you think? It'd be a curve, straight line, straight across and then up. What would it be? If he said straight line, you're right. But let's go with this scenario here. Okay, Emily's looking into the swamp, sees her friend Matthew yelling for help. He's in over his head. She knows he has to get to him as fast as possible. Which route should she take? Which way would you go to get here? Take a few seconds to think which way you would go. A, B, or C. So let's just go through in order. If you said A, your shortest path, or the first portion of your trip, would be a short trip on land. Where can you run fast on the land or slow? Pretty fast. And then you have a long trip through water where you're going to go pretty slow because you're going to have to swim or wade, and both those take time. Here's the straight line option, and that's where you have a medium trip through both media. And then here's our third option, a long trip on land and a short trip through water. Which of these do you do? Well, the answer is C. And the answer is always C. And this is not just for this exercise, but in real life too. If you needed to save somebody's life and they were in a pool or a lake, generally the idea is you run on land to the closest point to where they are in the water, and then you jump in and swim from there, because swimming is slower than running. Light follows the same rules. It's going to take path C. Hi, have a nice day. So light's going to follow the path of least time, and so that's why we get things like the bent straw. All right, that's why we get this. Light is following the path of least time. It's getting out of the water as quickly as it can, right, by bending, so that it takes the least time to get from point A to point B. And so that's why we see the image shifted. Really kind of an interesting concept to come up with. Okay, in the 1800s, Thomas Young did a double slit experiment. And we've looked at double slit experiments a lot. All right, you watched the double slit experiment last week, and we were going to do a double slit experiment in class tomorrow. If we would have been in class, you would have measured the diameter of your hair using a laser. But we can look at what this looks like. So there's a video here about a double slit experiment done by Mr. P, and some questions to think about. What does it mean for light to be monochromatic? Are areas of constructive interference red or dark? And if we just saw two dots, what would that mean? So this is a really interesting video about light interacting through two slits. All right, what happens when light passes through two tiny little slits? Boy, you gonna trip over that a third time? Second time. Okay, so that's it. That's the day. So I hope you enjoy. I really like this video. This is a video of him teaching class. And yeah, the oil experiment is super fun. So have a great day, and we'll see you again tomorrow.